Okay, so in this section again, we're going to look at lines again. Uh, in this section, we're actually going to start to look at, I guess, more geometrically. So I'm going to look at lengths of a line and area involving lines. So firstly, length then. So between 2 points, any 2 points here, say if we have this point at 1, which is x1, y1, and this point at 2, which is x2, y2, right? Very similar to when we constructed the gradient. So the line between it, okay? So the gradient we measured was the steepness of the line. So I guess how hard do you have to work to kind of walk up the line, if you were. But actually as well, we can actually also work out the length of the line, so that corresponds to the distance between the 2 points. Okay, now let's then we can work out this horizontal distance part here. Well, that's just a change in x, isn't it? It's like the gradient. The gradient is changing y, changing x. So firstly, the x down here. Well, this point is x2. Okay, take away x1, and that would get me the if I move this over here, there we are, there we are, x2 minus x1, that gives us the change in x. Okay, so the x, the horizontal bit there. Similarly then, if we go upwards, the vertical bit, well, y2 would be up here and y1 would be down there. So again, the change in y, as that is y2, and again that's y1, the change in y is the difference, right? So it's y2 take away y1. Cool. Okay, well then, hopefully you recognise we've got a nice little right angle triangle. Now, I mentioned that, well, what I want to find is the distance here, the length between the 2 points. The distance between the 2 points. If I call the distance d, then, no points for what d stands for distance. Well, what can I do with this? I have a right angle triangle and I have three sides. What kind of relationship, what can I do with everything here? Pythagoras, right? Because of a right angle triangle and have all the lengths here. So D is the hypotenuse, right? You can see that because it's facing or opposite to the right angle. So D is the hypotenuse. Now, Pythagoras theorem is a squared plus b squared is c squared. Well, I have all these lengths here. Y2 minus y1 there, x2 minus x1 here, and d here. So if d is the hypotenuse, then we can say d squared is this length, which is y2 minus y1, so all of y2 minus y1 and that's squared, plus this side here, which was x2 minus x1. And that'd be squared as well, corresponding to Pythagoras theorem. And there we are. So now we've got a way to work out the distance between the points using Pythagoras theorem. So again, if I do then change in y, which is this bit, so I could formulate this as change in y all squared plus change in x all squared. Okay, make this a bit clearer. There we are. If I do the change in y between the two coordinates and the change in x of the two coordinates and square both of it because it's a squared and b squared, I get the distance squared between the points, okay? And so therefore then, I can say distance then alone, because I've got d squared, but I want d on its own. Well, I can just square root both sides. So then I get root of y2 minus y1 all squared, which is the change in y, plus the change in x, so x2 minus x1 all squared. Okay, and that is going to be a very key pivotal formula that you will use in various other parts of the course, and it does come up a lot in papers as well, the exam papers. So yeah, but I would say this looks scarier than it looks. No, it doesn't look as scary as it looks. We'll look at examples, and eventually you will get very used and comfortable with this formula as you keep using it. But yeah, so this is the distance then. So you do the change in y, the change in x, then you just essentially do Pythagoras. So you square both of it, and then you get your distance. Okay, cool. So let's apply that then. So let's have a look here. Let's have a look at this example then. Find the distance between 2, 3 and 5, 7. So we know that the distance then, that's going to equal to the square root by using this formula here. The change in y firstly, so I'll do 7 take away 3, and that'd be all squared. Then I do add the change in x, so that's 5 minus 2 all squared. And then I could just put that in a calculator, right? And that will give me my distance. So where's my calculator? Let's just work it out. So this will be the root of 7 minus 3 would be 4 squared. 5 minus 2 would be 3 squared. So then that would give me 16 plus 9, which should be root 25, which should be 5. So that is my distance there. Great, okay. There we are. Okay. So yeah, so that's essentially the distance, right? You do the change in the y coordinates and the change in the x. Now the key thing to mention is, again, like with the gradients, you have to keep the ordering in mind. So if whatever you pick first for the y coordinate, the change in y, so we picked the second coordinate because 7 was first, right? Again, you have to match the ordering. So if you're doing the change in y, if you start with 7, you have to then start with 5 for changing x as well. You can't do 7 minus 3 and then like 2 minus 5, okay? Okay. Well, actually, no, you could, because you just get the negative, because then this would be negative 3. Normally that would matter, but then you're squaring it. But if you square negative, root minus 3 squared is the same as positive 3 squared, which is 9 anyway. However, it's really good practice to, you know, keep the ordering of what you choose, the position of which coordinate you choose first in mind. Okay, like with gradients. But yeah, there we go, distance then. Cool. Let's have a look at this. Got this example, and it says a straight line L1 with equation 4x minus y equals 0, and the straight line L2 with equation 2x plus 3y minus 21 equals 0 intersect at the point A. First of all, it says to find the coordinates of A. Well, if they intersect, then the coordinates when they intersect, so they equal each other. So these are just effectively simultaneous equations. So if I rearrange the first equation here, that means y would equal 4x, right? If I add y to both sides. Well, then I can substitute it in then. So I'm going to sub y into the other line equation, 2x plus 3y minus 21 equals 0. Then I'm going to get 2x plus 3y, so that's 3 lots of 4x, minus 21 equals 0. Then I have 2x plus 3 times 4x, which should be 12x, minus 21 equals 0. That means 14x minus 21 equals 0. Then I get x then is 21 over 14, which should be 3 over 2, I believe. Yes, okay. Well then that's x, and then I need y, the y value. But y is 4x, right? So y is 4x. So that's going to give me 4 times 3 over 2, right? And then that would be 6, right? 4 times 3 is 12, divided by 2 gets me 6, okay? Cool. Okay, so that means then, if x and y is 3 over 2 and 6, then that means the coordinate, which is A, is 3 over 2, 6. There we are, so that's part A done. Nice, we're used to examples like that at this point. Cool. Part B then, okay, says part B, right, work out the area of triangle AOB, where B is the point where L2 meets the XF. Okay, so now there's a lot going on in part B. So this is, again, is fairly common with with straight line problems. When you have multiple straight lines, you might be able to form different shapes like a triangle, which you can find the area of. So let's sketch what's going on. Okay, so this AOB. Okay, well let's draw an axis. Here. Okay, well, straight line L1 and this straight line L2 intersect at A. Well, A, firstly, is 3/2, 6. So that's going to be up here somewhere, right? So 3/2 is 1.5, so it'd be up there somewhere. Then O, well, O is the origin, okay? So that would be there at O. O will usually always be the origin if you see an O, but yeah. And B, well, where'd B be? Well, actually, it doesn't say exactly what it is, but it does say that B is the point where L2 meets the x-axis. Okay, so we need to work that out. Well, B, if it's on the x-axis here somewhere, then that means that it's on the x-axis, so y would be 0, so the coordinate would be x0, and we need to find the x coordinate there. Okay, so how are we going to do that? Well, we know that B, we told us on the line L2, but we know L2 has this equation here. So therefore, I'm going to sub this point into L2, okay? So L2 then will become 2x plus 3y, but y is 0 here. Minus 21 equals 0. Well then, I can solve this for x, because then 2x would equal 21. So x is 21 over 2, okay? And I guess that as a decimal, that be 10.5 if you wanted to write it as so, which then you should be, it makes it easier to plot because we know where it would be. Okay, okay, so then that's the point B, because now we know x is 10.5, well B is 21 over 2, 0. So B would be about, if you continue it, it's going to be about there, okay? And that's 21 over 2 at B. Okay, now it says work out the area of triangle AOB. So actually, then we need to connect all the points, and it should form a triangle. If you can draw a nice straight line. I don't have a ruler, but yeah. Okay, and then the axis there. So we have a triangle then. Cool. Hopefully you can see that. So it always is a good idea when you got sort of like shapes or some geometrical visual going on. It is a really good idea to always sketch the graph and see what's going on. So area triangle AOB. So then in general, to work out an area of a triangle, say this triangle here. Well, here, any typical triangle ABC. Or any typical triangle. We can work out the vertical height, which would be oh, I didn't mean to do that. The vertical height, so that's from the top of the shape there, and the vertical height is, or the perpendicular height is straight down from the top to the base. Okay, and that's H, and then obviously we got the base here. And so therefore the area of a triangle, when you've got the vertical height like this, its area is a half times base times height. And height again to echo is the vertical height up there. So from the top point, well, H in this instance would be that vertical distance there. From the point to A all the way down to that point on the origin there. Okay. And therefore the base then would therefore be that distance there, okay? Well then, we can work that out. So then H, because we know what all the points are, it really allows us to work out what the lengths are that we need to deal with. Well, H, first of all, again, is this that gap there, that distance between A and the x-axis. Well, that's just the y value of A, because A, the y coordinate is 6. Well, it's going from 6 to 0 then, isn't it? So that means the vertical, the perpendicular height, or literally the vertical height, is 6. Okay, And then we also need the base, so that's the length at the bottom of the triangle, which again is down there. Well, that's just 21 over 2, isn't it? Because it's going from 0 to b, which b is 21 over 2. So that means the base, or b, is 21 over 2. So now we can say that that's 6, and this is 21 over 2. Then we got our area then. Then the area of a triangle is a half times base, 21 over 2 times height of 6. Put that all that in a calculator, you should get 63 over 2. Cool. And there we are. And you may wish to specify units squared, okay? Because obviously that could be absolutely any measurement, but we just say units, and squared because we're dealing with an area. But really, that really doesn't matter. You won't be marked down for that unless it specifically says give a unit. But this is the numerical answer, 63 over 2. Cool, so that's the area. Okay, and that's basically what we do, right? We can use lines and coordinates by finding coordinates with lines like we just did. We found the coordinates of A, we found the coordinates of B. That allowed us to quickly determine the height and the base to work out the area of the triangle, okay? Or else we would probably use like SOHCAHTOA, half AB sine C and stuff like that. This allows us to work it out more quickly by using lines and stuff instead. And that's what we're going to look at in this section. More problems like that. Okay, and again, the key idea is to consider the visuals, right? Plotting the points or the lines and then see what you can do. Anyway, cool. So let's have a look at some more exercises. And actually, with the distance thing, then we can work backwards. And if we have a missing point or coordinate, if we're then given the distance, we can then work out the point. Okay. So it says the distance between the points minus 113 and x9 is root 65. Find two possible values of x. Well, we're given 2 points on the distance. We know the formula D is again the change in x, x2 minus x1 squared plus change in y, y2 minus y1 squared. Okay. Okay, well that's the formula. Well, we know the distance is root 65. Cool. And so then the change in x firstly is x minus 1. Well, x minus of minus 1. Because then if you take this point as the first point, well, x take away the other x value would be minus 1 all squared. Then we do the same for y, plus 9 minus 13 all squared. Oh, by the way, it doesn't matter what order you do it in this time round. In regards to do you do change in x first, changing x first, or changing y? It doesn't matter because we're adding these values. So addition, obviously, if you have two numbers, 7 plus 9 is the same as 9 plus 7. So it doesn't matter if you take x or y first, as long as the key idea is whatever point you pick first, you keep that point. You keep the ordering, right? So we don't do x minus x plus 1 and then do again it doesn't matter in this case. But yeah, anyway, it doesn't matter how you do things in this particular case. Anyway, we can work this out then. So we have root 65. We can simplify it to root of well, x minus 1 is a plus, so we have x plus 1 squared. Plus 9 minus 13 is minus 4 squared, but again that'd be plus 16 in the end. Okay, and we actually can't do anything more as it is. What we can then do then is actually well, actually you can spot that actually whatever's inside the square root, it must be the same in it because it's equal to each other. If the two square roots are equal, well then what's inside the square root has to be equal as well. So then that means 65 is equal to x plus 1 squared plus 16. You could think of it as alternatively squaring both sides, and that's completely fine. And I did mention in an earlier chapter, if you do square both sides, you have to check for something called an extraneous solution. So, for example, if we had root x was 1, I think, then if you squared both sides, you had x squared equals 1, and then x would be plus or minus 1. But obviously then, if you substitute minus 1 back into the square root, root minus 1 is 1, cannot happen. So when you're squaring both sides, like in this case, you have to check for an extraneous solution. That's an extra solution you get from squaring both sides. That may not work. But in this particular case, when we got two square roots like this, we don't have to worry about that. We could just compare inside the square root and then get this equation. Anyway, so now this is quite a nice quadratic equation. We just need to rearrange it a bit. So let's expand it. So x plus 1 squared, remember it's x plus 1, x plus 1, plus 16, and that equals 65. Well, I'm going to take away the 65, and that's equal to 0. Then I can expand the brackets to get x squared plus x is 2x plus 1 plus 16 take away 65 gets me minus 49 equals 0. And then I had x squared plus 2x and then minus 48 equals 0. And then this is a quadratic, right? And I can just use the formula, say. So then x would be minus 2 plus or minus square root of 2 squared minus 4 lots of 1 minus 48. So that's the coefficients a, b, c of a quadratic. And then that's over 2 lots of a, which is 1. And there we are. So put that in a calculator, you get that x is either 1, 2, you get x is 6 or minus 8. Cool. And there we are. So that is our two possible values of x, and both are actually valid, right? If you plug both of them back into this original formula here, though both x values, you should get root 65 into here, right? So yeah, they're both valid solutions. So cool. There we are. And again, that's a philosophy, right? That's usually at this point in exam questions, that's they might expect you to use the distance formula in kind of reverse. Given the distance, you need to find a missing value, right? In this case, this x point here. So you can do that by just equating the square roots together. Okay, cool. And a very, very similar example then, to really practice this. We have a point P that lies on the line with equation y is 4 minus 3x. The point P is the distance of root 34 from the origin. Find the two possible values of point P. Okay, so we are told that P lies on this equation here. Well, P, first of all, we're not told anything about either x or y of its coordinates, so we just call it xy, okay? We are told also that P is a distance of root 34 from the origin, okay? So that means distance from P from origin to P. How do I draw an O? There we are. From O to P, the origin to P is equal to root 34. Okay. Well, we know the origin is just 0, 0. So then we've got 2 points. Right. Again, we don't know what exactly P is, but we have 2 points. So we can use the distance formula. So root 34 is equal to well, changing x and changing y squared. Well, the change in x, if we take p first, well, it's just x take away 0 all squared, right? Take away the x values from p and the origin, x take away 0 all squared. Then the change in y, similarly is y minus 0 squared. We can simplify this bit to root x squared, because x minus 0 is just x squared plus y squared, and that's root 34. Well, then we can almost get rid of the square root, so we can equate inside the square roots together. So therefore 34 is simply x squared plus y squared. Okay, well, that doesn't well, it does help us, but we can't solve it. We can't immediately solve it right away because we have two values here, x and y. So I can't solve this equation on its own. However, we are told that at p, y is equal to 4 minus 3x. Well, hang on then, isn't this a simultaneous equations? I have two equations with y and x in. I can solve them now to find x and y. So if I call this equation 1 and 2, well, this is the quadratic simultaneous equations which we looked at earlier on in the course, where I had to solve them. We can use substitution. Well, here, we're already nicely given that y is equal to something. I can substitute y in, right? I can substitute y from equation 2 into the other equation 1. To then get 34 is equal to x squared and y squared, which is 4 minus 3x all squared. Then I get 34 is equal to x squared, and I'm going to expand this bracket, and I'm going to do that here actually, 4 minus 3x, 4 minus 3x. I'll tell you what I'm going to do, that I'm going to rearrange it on the other way around to minus 3x plus 4. Minus 3x plus 4. And then I can expand that bracket, so then that'll get me minus 3x times minus 3x is positive 9x squared. Then minus 3x times 4 will get me minus 12x. Then I'll do 4 times minus 3x is minus 12x again. Then I have plus 4 times plus 4 is plus 16. Therefore I get 9x squared minus 24x plus 16. So therefore that expansion again will then go to plus 9x squared minus 24x plus 16. And in general, it's not a bad idea if you need to do a tricky expansion, to do it like somewhere, just to make your working a bit neater, I guess, to not use as much space. So there we go. Okay, well then I can, this is a quadratic now, a quadratic equation, so let's simplify it. So x squared and 9x squared is 10x squared, and then have minus 24x, then have plus 16, but then I take away 34 equals 0, and then that'll go to 10x squared minus 24x, 16 take away 34 will get me minus 18. There we are. And now I need to solve this. Well, I think probably the best way again is just use the formula. Got quite awkward coefficients here. So x is then minus 24 is plus 24, plus or minus square root of b squared, which is minus 24 all squared, minus 4 lots of a, which is 10, c minus 18 over 2a, 210. And you put that in the calculator, you should get x is 3, or x is minus 3 over 5. And there we are. So we've got two values of x, but they told us to find two possible positions of p, so find two coordinates of p. So I need to find the y value as well. Well, we know that, let's go to our equations. Here, y is 4 minus 3x. So, if I repeat that, so if y is 4 minus 3x, then that means when x is 33, to find the corresponding y value, y would be 4 take away 3 of 3, and that would get me 4 minus 9, which should be minus 5. Okay, cool. Okay, so then that's when x is 3. What about when x is minus 3 over 5? Then y would be 4 take away 3 of minus 3 over 5. And so that would get me 29 over 5. Cool. So now we've got two values. We've got two pairs of solutions, x and y. Well, that makes up two possible coordinates of p. So p then would either be when x is 3, y is minus 5, or p would be when x is minus 3 over 5 and 29 over 5 for y. So those are the then two possible positions of p. Cool. Okay, so yeah, so that is quite a bit more tricky than the other question, but hopefully that makes sense now, right? And how we use the distance formula, and then how we arrive to these simultaneous equations to solve. Okay, let's have a look at this question then. So we are told the points are 5 minus 2 and S9 0 lie on the straight line L1, and they've given us the drawn all the information for us, so that's nice. First of all, it says work out an equation for the straight line L1. So again, L1 passes through both points R and S. So R is 5 minus 2 and S is 9 0. So then to find the point at the line L1 which goes through both points, well, I need the gradient and the y-intercept. So, well, the gradient first of all we can work out. Between the 2 points, the gradient is changing y over changing x. So changing y firstly, s is 0, take away the other y values, so minus 2, and then changing x would be 9, take away 5, and that would get me plus 2 over 9 minus 5 is 4 to get me a half. Cool. So then that means that y is mx plus c, so it'd be half x plus c. Then to find c, I need to substitute a point in to find that missing value. So let's take s then, which was 9 0. Let's substitute that in. So I'm going to say sub 9 0, and then we get that when y, well, y would be 0 here, and that's going to equal half x, or half of 9 plus c. Therefore, 9 over 2 plus c equals 0. Therefore, c is minus 9 over 2, which then gets us the equation y is a half x minus 9 over 2. Great stuff. Then for part B, no, it says the straight line L2 then is perpendicular to L1. So again, it would be like a right angle there. And passes through the point R here. So they intersect at the point R. Well, then it says find and work out an equation. So I'll do that here. Work out an equation for the straight line L2 now. Okay. So L2. Well, we know what the straight line L1 is. But we also know they're perpendicular. So I can consider their gradients, right? And in the last section we talked all about perpendicular and parallel lines. Perpendicular lines, their gradients are negative reciprocals. Okay, so let's. So firstly, we know the gradient of L1. Well, we worked that out in part A, right? The gradient was a half. That means then, as L2 is perpendicular to L1, that means the gradient of L2 is the negative reciprocal. So let's do reciprocal of 1 over 2, flip the fraction, 2 over 1, which is just 2, then have a negative, so negative 2. That means then our equation of L2 would be y is mx plus c, so minus 2x plus c. Okay, but I should use a different letter, plus d, okay, because I already use c here and the different numbers. So yeah, cool. Okay. Well then, to find the missing y-intercept, the d, well then I need another point. I need a point to substitute into this equation. So what point lies in L2 then? Okay. Let's have a look. L2 is that line here, that line there. Okay. Well, we know that R and T lie on L2. Well, we don't know anything about T, but we know what R is. R was given to be 5 minus 2. Okay, so R equals 5 minus 2. So that's what I'm going to substitute into the line. So then if y is minus 2, then I get minus 2x, which is at 5, plus d, okay? So then minus 2 is equal to minus 10 plus d. Therefore d, if I solve it, if I add 10 to both sides, I get positive 8. Cool. Therefore our equation is y is minus 2x plus 8. Great stuff. Okay. Then part C says work out the coordinates of t. Okay. So that is t's on the line L2. Well, we just worked out the equation of L2. We can use that here. Well, t is the y-intercept. Okay. So that means that that means therefore that t well, t is the y-intercept, that's when x is 0, but then the y-intercept is 8, right? Remember mx plus c. The c is the c is the y-intercept, okay? And m was the gradient, okay? So we can easily read off that therefore t is 0, 8. Alternatively, if you didn't realise that, you should hopefully at least realise it's on the y-axis. That would mean x is 0. So then you substitute x is 0 into that equation, and then you would get y would be 8, which would then be the y-intercept there. Okay, and so for part D, then it's asking us to work out the lengths of RS and TR, given an answer in this form of k root 5. Okay, so that's a third right, but we know how to deal with those. But what's it asking us then is, well, the length of RS, it wants the length of this line here between R and S, the points there, and likewise the length between T and R, so that distance there. Okay, roughly there, but yeah. But we know how to work out the distance between 2 points, don't we? It's the distance formula, the Pythagoras. So then if I just restate the points again, so R was 5 minus 2, S is 0, 9, for start, no, 9, 0, sorry, my apologies. Okay, well then firstly, the distance RS, so the distance between RS, well, again, that's the Pythagoras, so it's the distance between the 2 points. So we need the change in x squared. So firstly, the change in x. Well, let's take s first. So we have 9. Take away the other x at r, which is 5, all squared. Then we do the same for y. So change in y, so 0 here. Take away the other y value of minus 2. So take away minus 2, and that'd be squared. If I then put that in a calculator, well, I'll work this one out manually, just to show you. But then we have square root of 9 minus 5 squared, that'd be 4 squared. And then 0 minus 2, again that's going to be a positive. We're going to get plus 2 squared, okay? Then that would be root 16 plus 4, which should be root 20. Well, root 20 is a third. We can split that up into, because it says our answer needs to be in k root 5, so it has to look like this. Well, yeah, remember thirds, we look for square factors, so factors that are like 1, 4, 9, 16 and so on. That well, here I can spot 4 goes into 20, so I can say that's root 4 times 5, and then 4 is the square factor. Then I can split up to root 4, root 5. Remember, with thirds, root AB, I can split it up to root 8 times root B. Remember that third law? We did in the first chapter. Then root 4 is 2, so that'd be 2 root 5. Cool. So there we are. We've got it in the form in terms of root 5. Then we need the distance TR. Yep, the distance TR there. But again, it's the same sort of idea. So then the distance between T and R, I need the square root of the change in x and change in y. So first is the change in x. Well, I'm going to, if T is 0, 8, here, I'm going to restate R again. So R is 5 minus 2. So let's write it over here. Change in x then. Let's do r here, 5, take away 0, which is the x coordinate of t, all squared, then a change in y. So I have minus 2 here, take away 8, and that'd be squared as well. Now, I'm going to just put that in the calculator. Okay, so square root of 5 take away 0 is just 5 squared, then plus minus 2 minus 8, which is minus 10, and that'll be all squared. That should get you 5 root 5. Okay, and again, that's in root 5. That's in terms of root 5, so yeah, we've done it. So there we are. So that's the distance, distance RS, so the distance between points R and S, and the distance between T and R. Cool. Part A then says work out the area of triangle RST. Well, okay, so consider the points R, S, and T. To draw a triangle. Well, T and R are connected, and R and S. Then we just need to draw the hypotenuse between T and S, and that'll get me my triangle there. Okay. I'm probably just going to do that here then. So again, so we can use the diagram already given to us. So let's draw it there. I can't get it as straight as straight as I'd like to, but we'll take it. So remember, the area of a triangle then is the vertical height and the base. Well, the base is R and S, right? But we worked out the distance of R and S, the length of R and S already. RS was 2 root 5, so that would be my base, okay? Then the height, now the vertical height, or the perpendicular height is there, okay? So the height from the very top of the triangle to the base. So that is the distance there, which is h. Well, again, that's just the length tr, isn't it? That's the distance from t to r. Well, t to r, well, we worked that out as well. It's 5 root 5. Okay? So therefore, that'll go to 5 root 5. Well, if that means then the area is a half times base times height. But the base is 2 root 5. And the height is 5 root 5. Okay? Therefore, there we are. So we put all that in the calculator. We're going to get... Although you could easily work that out mentally, well, not mentally, but by hand, but I'm too lazy. If you do that, you should get 25. There we are. And again, we could call that unit squared if you wish. But there we are. 25 is the area. Cool. So you can see the usefulness of finding distances and lengths, which then you can use to find areas of shapes, okay? Because once you find the sides, the lengths of the sides, then you can use the area formula. Cool. Let's have a look at another question then. Okay. Okay, this is more of I covered an example kind of like this last time. We can use lines and to prove certain shapes. Okay, so properties of a shape. Now, so we are given 3 vertices of a triangle A, B, C, and we need to prove it's a scalene triangle. So last time we proved something was a trapezium and a rectangle. Now we need to prove it's a scalene triangle. Now, and my tips and my strategy will be the same as back then, last time. So my tip being, let's just consider plotting the points. Okay, so if we have an axis then. X, Y. Well, firstly, let's put A. A is 2, 7, so it's probably going to be up there somewhere. Then B is 5 minus 6, so that's going to be down there somewhere. And then C is 8 minus 6, so that's going to be down there somewhere, okay? Then we can connect the points, and there we are, okay? So that is what our triangle will look like. Cool. Right. Okay, so we need to firstly prove it's a scalene triangle. By the way, I should write the coordinates in as well. That will help. 2, 7. B is 5 minus 6, and C is 8 minus 6. It will come in handy. but there we are for now. So proving it's a scalene triangle. You probably not heard that very often. It doesn't come up very often, but a scalene. So you got an equilateral triangle, which is all sides and therefore angles are equal. You got isosceles, which two of the three sides of the triangle are equal. Well, scaling, I guess, is none of them are equal. So actually, scalene triangle means that all sides are different. Okay. Well, okay then, so we need to work out the lengths of all the sides. But how can we work out the lengths of all the sides? Well, we got all the points of all the vertices. How do we find the distance between any 2 points? The distance formula. So let's get cracking then. We're going to need to use it 3 times though, because we have 3 sides. So let's get cracking. So firstly, the distance between AB. So let's call that AB. So firstly, the distance, so the length of this line here, of AB. Well, that's so then that's just the square root of the change in x and change in y again. So change in x for B, let's say 5 take away 2, which is at A, squared, then plus the change in y, so that'd be minus 6, take away 7, all squared again, and then put that in the calculator. We should get root 178. Okay, not a nice number, but it doesn't matter. Okay, AB's that. Then what the other sides we got to work with? Let's work out BC. Let's work out BC. Okay, so that would be now looking at the distance of that side, that length. Okay, that side there, BC. Again, we're going to do the same thing. So square root of the change in x firstly. So let's take C as our first point. So 8, take away the other x value at 5, all squared. Then change in y, so minus 6, take away minus 6. Then we should get that would equal, put that in the calculator. So root 8 minus 5 squared plus minus 6 take away minus 6 is plus 6. So minus 6 plus 6 is 0, but you put that in the calculator, you get positive 3. Okay, cool. Then the last side we've got to work with is AC. Okay, that's the remaining side. Again, to work out distance, do the change in y, change in x of both A and C. So again, I'm going to take C first. So let's do change in x. So we're going to have 8 take away. I have to keep scrolling. 8 take away 2. So that's the x value at A, all squared, plus the change in y. So minus 6 take away the other y value at A, which is 7. Okay, cool. And that be squared. Therefore, put all that in the calculator. I'm going to get 8 take away 2 all squared, plus minus 6 minus 7 all squared. I get root 205. Okay. Well, there we are then. Well, we've worked out the length of all 3 sides of the triangle, and none of them are equal. So, AB is not equal to BC, which is not equal to AC. Okay, I guess I could just say that therefore all sides AB, BC, AC have different lengths. Okay, therefore it must be a scalene triangle. So triangle ABC is a scalene triangle. Cool. As all sides are different, okay, because that's the defining property of a scalene triangle. All 3 sides are different. Cool. Okay, that's not too bad, I guess. And then parts B, I'm going to do part B up here, actually. I'll do part B up here. I don't need much room for part B actually. Then it says find the area of triangle ABC. So we proved scaling. Now we need to prove it's a area of triangle. You need to find the area. Well, it's the same thing. Okay, we need the base. Now the base is going to be that distance there, which is BC. Okay, I'm going to say the base is equal to BC, but we worked out what the length of BC was, didn't we? BC was 3. Oh God, BC here was 3. So the base is equal to 3. Then the height, uh, which is the perpendicular or the vertical height. Now it's not going to be this here. That's not going to be the vertical height. The vertical height is literally a straight. It's completely vertical. Well, it's a vertical height, so it's completely straight. This will be a slanted height. As you can see, AB is like a slanted line. What the completely straight vertical line is, again, it would be if I extend the top of the line here of the triangle, it's literally going to be down here, right? That is the vertical height. If I draw that again, there. So from the very top of the completely straight line, completely vertical line that goes from the top level of the triangle to the bottom, to the base. Okay, not the slanted height. That's slanted height. Okay, I want the completely straight vertical height, which is this, and that would be H. Okay, now that's not really what we worked out. We worked out the lengths A, B, B, C, and AC, but that's not this height here. But this height's very easy to work out because we have all the points, though. Well, isn't this height just the well, we know the y value at A, we know that's 7, and it's going towards B at the base. Or actually, no, it should. Yes, at B. Actually, I should reconstruct my triangle a little bit because B and C have the same y value. So actually, C should be on the same level as B. So my triangle would look like that. Okay, so it's a nice flat base. Okay, because if C was down here, then a base would actually go from up here to down there. But it doesn't matter in this case. Anyway, the height again is from the top A, the top level, to the bottom level. Okay, so that's the vertical height, H. So we know at the top the y value is 7. Then at the bottom, well, it's -6, right? -6 there. So I want the distance between 7 and -6. Well, that's going to be 13, isn't it? Right? So, because you want to first get from 7 to 0, that's 7. Then you go underneath by another 6, right? So in total, you get the height is 13 there. Okay. So the vertical height from the top of the triangle, the top level, to the bottom level, the vertical height would be 13, because the y value at A is 7, and at the bottom it's -6. So the total height from 7 to -6 is 13. Okay, so the height is 13 there. Therefore, we've got our ingredients for the area. So area is a half times base, which is 3, times the height, which is 13. And that will get me 39 over 2. Cool. There we are. Lovely. So again, it's the exact same sort of philosophy, right? Finally, you can use the lengths to find the area of of a triangle, and you can also consider the coordinates to consider the vertical height. But yeah, cool. There we are. Okay, we're going to finish off with this exam question then. Oh, go up there. So we're given a sketch of some lines, and it says the line L1, let me scroll up, the line L1 has equation y is 3 over 5x plus 6. The line L2 is perpendicular to L1 and passes through the point B, which is A0. Well, that's shown in the sketch. Show that the equation of L2 is 5x plus 3y is 40. Now they're perpendicular, so again they're going to be at a right angle. Now, so they're perpendicular, so we're going to have to consider gradients, okay? Well, we're given the equation of L1 in it's in y equals mx plus c form. Well, that means the gradient of L1 we can easily read off to be 3 over 5, right? 3 over 5 is the gradient there. Cool. That means, therefore, we know the gradient of L2, well, they're perpendicular, okay? So that means the gradient of L2 is going to be the negative reciprocal. So let's negate it and do the reciprocal. So flip the fraction to 5 over 3. So there we are. That means then we can then get an equation of L2. So y equals mx plus c be minus 5 over 3x plus c. Now we need to find that c value, okay, the missing number there. Well, we need to know a point on the line. We need to know a point on L2, okay, to substitute into to find that C. Well, let's have a look. L2 is down here, but we're told it passes through this point B, and we're told that B is 8, 0. Well, there we are. We got a point to substitute into, so I'm going to say sub 8, 0 into here. That will get me then that y, well, y is 0, so 0 would be minus 5 over 3 of 8 for x plus c. Therefore, minus 5 over 3 times 8 would be minus 40 over 3. Plus c equals 0. Therefore, then, I can easily say then that c is 40 over 3. And therefore, our equation is y is minus 5 over 3x plus 40 over 3. Okay, but we need to show that the equation rearranges to this. So that means, firstly, I notice x and y. Oh, I didn't mean to do that. There we are. X and y are on one side. Okay, so let's put move the x part to y. So that means 5 over 3x plus y equals 40 over 3. Now it wants to equal 40 the number, so I need to leave that 40 over 3 where it is. Okay, well then lastly I need to get rid of there's no fractions in my answer, so I need to get rid of the fractions here. So they're both out of 3, so I can just times by 3 to eliminate both of them. Therefore, times both sides by 3. I then get 5x plus 3y is equal to 40. Well, what do you know? There we are. We got the equation they wanted. Great stuff. Then part B, I'll do over here. Then we're given some more information. We are then also given that the lines L1 and L2 intersect at the point C, where we can see that there, right? They intersect at C. And the line L1 crosses the x-axis at A. There we are. Then it says, find the exact area of triangle ABC, giving your answer as a fully simplified fraction in this form there. Okay, so we need the area of triangle ABC essentially. So again, where would that triangle be? Let's try and sketch it. Well, A, B, C, Z. So if we connect those 3 points, the triangle we have is there, there, and there. Okay. Now, again, well, in order to work this out, I need all 3 points. Well, I know what B is. B is 8, 0, so that's going to be 8 there. But I don't know what A or C is. So I need to work that out. However, I now know both equations of each line. So I can then just use the equations of the lines to work out the missing points. Firstly, C. Well, C, I'm up here. I'm at C. Both lines intersect each other. That means they're going to equal each other. So so that means the equation of L1 is y is 3 over 5x plus 6, and the other equation L2 is 5x plus 3y is equal to 40. So that would mean they equal each other because they intersect at that point. So if I equal them, well, I can substitute the top equation for y into the other equation for y there. So I'm going to sub y into the equation 5x plus 3y equals 40. Then I'm going to get that 5x plus 3y, which will now be 3 lots of 3 over 5x plus 6 equals 40. There we are. Then I can expand this out, so I get 5x plus 9 over 5 plus 3 times 6, which is 18, minus 40 equals 0. Then I can collect the x's, so there's an x there. So 5x plus 9 over 5x, so do 5 plus 9 over 5 on my calculator. That's 34 over 5x, okay? And then I get 18 minus 40, which is minus 22, equals 0. Okay, but therefore, 34 over 5x equals 22. Now, to get x, I can then just divide by the fraction. Divide by 34 over 5 to both sides. To then get x is 22 divided by 34 over 5, which will get me, if I put that in the calculator, that x is 22 divided by 34 over 5. I get 55 over 17, okay? There we are, so that's my x value, but then I need the y value, so I need to substitute that x value into an equation again. Well, let's substitute it into this one. This is the nicest one. So that means y is 3 over 5x plus 6. And that's going to equal then 3 over 5 of x, which is 55 over 17, plus 6. And so that will get me, for time do it on the calculator, 3 over 5, lots of 55 over 17. Then I add 6, I get the fraction 135 over 17, okay? Therefore, that's the x and y, so the point, which was C, remember, C was the intersection, so that would be the coordinate 55 over 17, 135 over 17. Cool. Should make that a bit clearer, that's a 5. Oh. There we are, great. So that's our C coordinate. Now I need to find the A coordinate. So, because that's part of the triangle. So A, well, what's special about A? It's on the x-axis, right? So, we know that y is 0. So let's deal with that. So we know A is on the x-axis, so x and y will be 0. Okay, well then, how do I find the x-coordinate of A? Well, I know that A, as you can see, lies on L1 there. Well, if it lies on L1, I know the equation of L1 is this, so I can substitute that point A into that equation. So I'm going to say sub x0 into y is 3 over 5x plus 6. I believe that's the equation, right? Yes, okay. Therefore, I get that, well, y be 0, so 0 equals 3 over 5 of x, which is, well, x, plus 6. That means then that 3 over 5x is minus 6, so x then, if I divide by 3 over 5 to get rid of it, so x on its own would be minus 6 divided by 3 over 5. I then get minus 10. Cool. That means that the point A is minus 10, 0, okay? I guess I could fill that in. My on my graph there to help me. And C was the point 55 over 55 over 17. What was the y value? Oh, yeah, 55, 17, 135 over 17. Okay. Okay, so now we got all the points. Was it 137? No, 5. Okay, there we are. Okay, so we've got our points then. Now we need to find the area of this triangle, ABC. Now, the base, firstly, I'll do that up here in this space. So the base, well, the base is going to be, if I do minus 10 there, the base is again between A and B. So it's the length AB, but A is minus 10 and B is 8. So to get from minus 10 to 8 is going to be 18, okay? So again, firstly, you can think of this as minus 10 at A to 0. That's 10 we've moved. Then we need to go from 0 to 8, which is another 8. So in total it's 18. So the base is 18. Now I need the height. Now I need the vertical height, completely straight vertical line. So this height up here from the top of the triangle, which is C, to the bottom. So the top to the bottom is that height there, which is H. Now, the height then, again, the height, isn't that just from the y value of C? Because C, the y coordinate was 135 over 17, right? There. So we're going from 135 over 17 to the x-axis at 0. So therefore the height is simply 135 over 17, right? That's the vertical distance from the x-axis to C. Okay, C, the height of C is 135 to 17, which is the y value. There we are. So now we've got our ingredients to find the area. So therefore the area of the triangle is a half times base of 18 times by height, 135 over 17. And then you do all that, put that in your calculator, you get half times 18 times 135 over 17. You get, okay, 1215 over 17. There we are. And again, you call it units squared if you wish. Well, there we are. That's the area. And so it says we need to give out the exact area. So that means no decimals, no rounding. Like if you cannot get a physical number to write down, just leave it as a fraction or third or whatever. And yeah, so it says give me as a fully simplified fraction of this form here, P over Q. Well, I put it in my calculator, and the calculator will give you the most simplest answer. So I cannot simplify 1215 over 17 anymore. Okay, so that's the final answer. So you could then say that if I compare it with this, P is the top number, but Q is the bottom. So then if I compare my answer, P would be 1215 and Q would be 17. There we are. Good stuff. Oh, okay. Okay, yeah, so yeah, that's essentially it. Cool. So hopefully you saw in this section then how we can find the distance between 2 points by essentially doing the Pythagoras. So the square root of the change in x's and the change in y's of the two coordinates. That then allows us to then perhaps find the area of a particular shape, usually a triangle, by then finding all the sides, okay? And then we can also use the coordinates perhaps to find the base and the height of the triangle, which then allows us to use half AB, half times base times height to get the area. Okay, cool. So hopefully, these examples have helped. And again, a key tip: draw the graph if you can't. If it's not given to you, it really, really helps to visualize what you need to do and what the different sides or the heights of the bases are of the shape. But yeah, I'll leave that there then. I'll see you next time.